now today we will be working on a simple neural network. You are able to view my screen. So here I just want to, this is called as in a any neural network. It can be a feed forward neural network, or it can be a recurrent neural network, or it can be a convolution neural network. So they're going to be input layer, they're going to be hidden layers, and they're going to be output layer. So now hidden layer can be explained, or input layer can be started as input x1, input x2. So in order to transfer the signal from this input layer to the hidden layer, you need to have a certain amount of importance. So we call that importance as W1 and W2. So now in order to send the signal from here to here, you need to have the weights. So now we discussed about gradient descent. So in order to optimize that weights, means if you are able to look on to the linear regression equation, y equal to, so wx plus b. So to identify your w value and to identify your b value, instead of using the straight line technique or using a least square technique, we are trying to calculate it with the help of gradient descent technique, so with an optimization, so in a random way. So by doing it for multiple iterations and by changing the learning rate, we are able to achieve it. Now let us try to see how exactly the information is doing. So before we are jumping into this particular thing, let us take a small example. Like let us take a particular input data. For example, the input comprises of 3 nodes, whereas each node x value is x1, x2 and x3. So now if there is your output signal, this is our output signal. In order to send the information from this particular input layer to this particular output layer, so now the equation at the output is y equal to, so w1 x1 plus w2 x2 plus w3 x3 plus bias. So this is more like your multiple linear regression model. So now into this particular equation, now if I want to go for a neural network which comprises of, so let me take one more. So in order to build a neural network, multi-layer neural network, or even we can say multi-layer perceptron. So in order to go for a multi-layer perceptron, so I'm choosing one input layer, one hidden layer and one output layer. So in the in the input layer, you have 3 input nodes, x1, x2 and x3. So in your hidden layer, you have 2 nodes, h1 and h2. And in your output layer, you have the equation y. So let us understand how these things are linked. So now the information from this input layer is flooded to this hidden layer. So from all the input nodes, the information is pushed to the hidden layer. So now the equation at this particular hidden layer is equal to, so h1 is equal to, so w1 x1 plus w2 x2 plus w3 x3 plus bias 1. So the equation, again the information need to flood from this input to this hidden node. So in order to send the information from this input to this particular hidden node 2, the equation at hidden node 2, h2, is equal to w3, we have it, so it is w4 x1 plus w5 x2 plus w6 x3 plus bias 2. So the same input parameters, but the weights are changing. Again, how the weights are getting updated with the help of our gradient descent optimizer. So once we got it, we need to send the signal. So from this particular hidden nodes, we need to send the signal to our particular output node. So the equation at your output, y equal to, so w6 we have it, so w7 h1 plus w8 h2 plus bias 3. So this is the equation whenever you are trying to use a very simple linear regression model So it is not a linear regression model. This is a neural network, we can say. So now, but if you are looking onto the y, basically in a linear regression model, the y going to be w1 x1 plus w2 x2. But here in the neural network, instead of having x1 x2 x3, we will be having the hidden nodes. So again, it's not still a neural network. There is a lot of topic we need to add on top of it. Now we are able to take a hidden node 2. Now the same thing, if you are able to look into this particular example, now we have a simple neural network which comprises of 2 input nodes, and we are able to have overall 4 hidden nodes in a single hidden layer. So if you want to form an equation, so h1 equal to, so w1 x1 plus w2 x2 plus bias 1. So if you want to write it down for hidden node 2, it is w3 x1 plus w4 x2 plus bias 2. So if you are writing it for hidden node 3, so it is w5 x1 plus w6 x2 plus bias 3. If you want to write it down for h4 hidden node, it is w7 x1 plus w8 x2 plus bias 4. So now when you are able to write it down for an output node, output y equal to, so w9 h1 plus w10 h2 plus w11 h3 plus w12 h4 plus bias 5. So this is how the equation going to be. If it is a simple neural network with 3 layers: input layer, hidden layer, and the output layer. So in the very forward pass, so whenever you are going to a neural network, this is a forward pass. So when you are going with input layer, hidden layer, output layer, it is a forward pass. Means the weights are allocated. After allocating the weights need to be updated. So how exactly we are able to update the weights? So once the weights are allocated, how we are able to know whether these weights are right or whether these weights are wrong? So again, let me rewrite this. If you are able to look back to this particular neural network, when you are able to look onto this simple neural network, now we are allocating weights like w1 x1, w2 x2. So how we are able to know whether these weights are right weights or not is with the help of loss function. So we are able to understand it with the help of loss function. So the loss function equal to, so mean squared error, or we have mean absolute error, where the mean squared error equation is y actual minus y predicted whole square by n. So now when the difference is close to 0, the weights which we updated are accurately right. In case if the weights are not accurate, then what we need to do? So now this is defined, the loss function is defined as E. Again, let's go to the neural network. The loss function is defined as E equal to y actual minus y predicted by n and its whole square. So the value of loss need to be close to 0. If the value is not close to 0, in case if it is 0, we no need to change the weights. So when your loss value is close to 0, you no need to change the weights. But when the value is not equal to 0, then you need to change, then we must change the weights. So how we are able to change the weights? So it is called as dou E by dou W. So the change in loss based on change in weight. So what exactly dou E by dou W? The change in loss based on change in weight, we call it as. So when you are able to go with change in loss based on change in weight, we are able to get the updated weights. Based on the updated weights, again we calculate the loss function. So this is the same thing we learned it on our previous gradient descent equation. So we are trying to calculate the new x value and we are substituting that back into the equation, and until we are able to get the loss value 0, we are keep on iterating it. So that's what we done. The same procedure, instead of x value, here we got weight value. The change in loss we are trying to calculate with the help of change in weight. So now the change in loss based on change in weight, this technique is called as back propagation. So this is called as back propagation. So this back propagation topic we will be discussing in our next video. So there we will be getting connected with more topics. See you in our next video. Thank you.